Hey everyone, we're up for our next example, example 5, which we are still applying the same theorem we used in example 4, you guys. So it's going to be just as exciting, so get ready for it. Guys, so again, we have segments that are intersecting outside of the circle this time, okay, and we want to find what the measure of angle x is. So remember at the top I squeezed in those directions, so we are trying to find the value of x in each of these 3 examples, but we're not on 6 yet, so don't look at that. It's a secret. Don't look at it. Don't look at it. All right, but anyways, so we have 2 different, in this case, rays that are intersecting outside of our circle. So what are these 2 types of rays called if they hit the circle in exactly one spot? Insane, you guys. They are tangents. You're correct. So in this case, we have 2 tangents that are intersecting outside of our circle. So our 2 tangents, I'm going to go ahead and label them so we know what we're talking about. Okay, so our tangents are ray F to the E and ray F to the S. All right, and since we have 2 pieces that are intersecting outside of the circle, okay, in this case they could be lines, they could be rays, they could be segments, sorry, but in this case they are rays. Okay, so we need to think back to that nifty property on the Prezi video. Oh man, guys, so remember this property says that the measure of an angle formed by secants and tangent lines that intersect outside of the circle is half the measure of the difference of the 2 intercepted arcs, which I told you the way that I refer to that is the outer arc, so the arc furthest away from the outside angle, minus the inner arc, which is the arc that's closest to the angle that's outside of the circle. Okay, so in this case, we're looking at 2 tangents, so we're more specifically looking at this lovely case right here. So let's take it in. All right, so oh no. No, that's not what I wanted to do. Ah, the demon cat's coming. Sorry, guys. Come on, come on, come on, come on, come on. Okay, sorry, guys. Let me zoom back in again. Let's try not to mess this up this time this long. Jeez Louise. Okay, but anyway, so in this case, we have 2 tangents that are intersecting outside the circle. Okay, so same property, just different kinds of segments. So we have 1/2 the measure of the 2 intercepted arcs, which is the arc furthest away from it, the outer arc, minus the intercepted arc, so the arc that is the closest to the exterior angle. Okay, so that's all we're going to be doing, again, just with 2 tangent lines instead of a tangent and a secant like in this first one. So same idea, just different kinds of geometric objects that we're dealing with. Okay, let's dive into the problem solving because that's where the fun begins. Okay, so I'm going to set this up. So based on that theorem, I know that the measure of angle F equals my outer intercepted arc, which if we're looking at our picture, what is the arc that is furthest away from this angle right here that it intercepts? It is in fact arc E to the H to the S. It is a major arc. Look at that right there. Okay, so it's going to be the outer arc minus the inner intercepted arc, which is the arc that's closest to the angle, which in this case would be this little guy right here, arc E to the S. All right, let's start setting this thing up so we can solve. Let's do this thing. All right, so the measure of angle F equals my outermost arc, so the arc furthest away from this angle that it intercepts, which in this case, the tangent lines kind of go off the circle, so pretty much most of the circle is inside of these tangent rays. So we have to be careful. So we're actually going to get the whole circle when we get done, which is going to be cool. Okay, so the measure of angle F equals my outer intercepted arc, which is this pink guy right here. So 1/2 the measure of arc E to the H to the S minus the measure of my inner and intercepted arc. That's always hard to say. Intercepted arc. Try saying it. Don't judge me because it's hard to say. All right, so my inner intercepted arc, which is arc ES. All right, let's set it up, and then once we solve it, we'll be done, which is kind of sad. I don't want it to be done. Don't end. All right, I'm going to fill in my values real quickly. So the measure of angle F is secretly the x right here. So I'm going to make that an x degrees equals 1/2 times the measure of arc EHS. Oh no, you guys. We don't know the measure of arc EHS. It did not tell us. I do know the measure of ES though, so I'm going to put that down before I have a panic attack right here. So this is going to be 132 degrees. So I need to find this missing piece right here that I currently don't have. Guys, so if you look here, the outer arc and the inner arc make up the entire circle. How many degrees are in an entire circle? Gee willikers, you guys, it is 360 degrees. So if my innermost arc is 132 degrees, what would I do to find the measure of the remaining circle, which is my outer intercepted arc? I would subtract it from 360. So we're going to do 360 minus 132 to get the measure of arc EHS. Okay, which 360... So I'm going to do some side work for the measure of EHS, which I just noticed I didn't put a little arc symbol. Ah! Geometry's so nitpicky. You can't forget those symbols, Miss Long. What are you doing? Ah! Alright, but anyways, let's keep going. So the measure of arc EHS is going to be 360 minus 132 degrees. Okay, which I'm just going to do it mental math style because that's the way I like to do it. So I'm going to subtract 360 minus 130, which 360 minus 130 will give me 230, minus 2 more will give me 228 degrees. Holy hot dog. So the measure of arc EHS is going to be 228 degrees, which let me just double check because I like to always check my work. Yes, it looks fabulous. It's 228 degrees. All right, guys, so now I can finish solving. Let's do this thing. All right, so x is going to equal 1/2 times whatever this bad boy is subtracted. So 228 minus 132, again, I'm going to do some mental math because it's fun. But anyways, all right, so 228 minus 100 is going to give me 128. Okay, and then take away 28 more will be 100. And then 28 to 32 is 4 more. So this is going to be 96, I'm pretty sure. But let me double check again. Yes, that looks good. I'm just going to double check. It doesn't hurt to double check, you guys. Just in case the demon cats are getting me right now. I just want to make sure that that works out. So let's see if I get 228 when I add this together, just real quickly. Sometimes I don't trust my mental math, especially when I'm doing math this late at night. Okay, so I'm going to do 132 plus 96 just to double check. So 8, 12, look at that, shazam. Okay, so it is 96 degrees. Yes. All right, let's keep going. All right, and then half of 96 degrees will give me, I'm pretty sure, again, I'll double check because it's late and I'm getting sleepy, so I better double check my work. So half of 96 is going to be 48, I'm pretty sure. Yes, it is. All right, guys, so the measure of x is 48 degrees. And guess what, you guys? It asked me to find the value of x. So in this case, I'm done so with that problem. That was fun, you guys. Example 6 is going to be just as fun. Get excited.